Good morning, guys. Let us solve one simple Olympiad question. Number of diagonals in a polygon. Right. So the questions are generally given number of diagonals in a 100-side polygon or 50-side polygon, etc. This is a basic question. This you don't find this in advanced Olympiads. In the preliminary test, you can find this question. You find this question. Right. Number of diagonals in a polygon. Right. We all know in a square, rectangle, rhombus, parallelogram, four sides, there are two diagonals. Right. We all know. Now let us explore a bit and try to create a generalized formula. Let us take this is a five-side polygon. Right. Pentagon. 1, 2, 3, 4, 5. Five sides are there. Now if you see, take one point. Let's take this point. How many diagonals we can draw? We can draw 1, we can draw 2. We can draw only two diagonals. From this point also, we can draw 1, we can draw 2. From any point, you can draw two diagonals. Okay. So what do you see? If you take one point, the point immediate right to it and immediate left to it, you cannot draw diagonals because these are sides. The point connecting to the immediate right and immediate left, right, of this side of this point, they are not diagonals, they become sides. And you cannot draw a diagonal to itself. Right. So in any polygon, for any point, 1, 2, 3, for 3 points, you cannot draw diagonals. If you take any point, you can draw how many diagonals? Whatever are the total number of points minus 3. Because 1, 2, 3, you cannot draw diagonal for 3. Right. If there are 5 points, then 5 from each one of the points, you can draw two diagonals. Right. Now again, you can draw a diagonal from here to here, but at the same time, the same diagonal you can draw from here, this diagonal, and this from here, that is this diagonal. So there will be double counting. Right. So from each point you can draw n minus 3 diagonals, because you cannot include that same point and left point and right point. So there are n minus 3 diagonals from each point, and there are n points. So n into n minus 3 total diagonals are there, but each diagonal is double counted. That means a diagonal, for example, this diagonal, you will count from here also, you will count from here also. Right. So each diagonal is counted twice. Any diagonal if you take. This diagonal is counted from here also, from here also. So in this n into n minus 3, there is double counting. So we should divide by 2 to get the correct number of diagonals to avoid the double counting. Every diagonal is counted twice. So total number of diagonals is n into n minus 3 by 2. This is the correct answer. So for example, if it is square, 4 into 4 minus 3, 4 into 1 by 2, which is 2. So if it is a pentagon, 5 into 5 minus 3 by 2. So this is 5. So 1, 2, 3, 4 and 5. So this thing is already done. This is repeated. This thing is also counted. This is also repeated. This thing is also already counted. So there are only 5 distinct diagonals. So this is the formula. How we derived? From each point we can only draw n minus 3 diagonals, because to itself we cannot draw to the one to the left, to the one to the right immediately, to the one to the left and immediately to the right we cannot draw, because they will become sides. Hope you understood this. Thank you guys. All the best.